All right. So today we're going to do page 45, which is 6-12, which is the last section of this unit, which could only mean, let's see. The nice thing about 6-12, am I reading this right? So then on Friday, which is tomorrow, we will do the 6-8 to 6-11 review. And then Monday, we'll be sure to go over the review. Tuesday, y'all claim that it's senior ditch day. Wednesday, we wouldn't have class. Thursday would mean let's make sure that our review is truly, truly, truly done. And then Friday, next week, we have our test. Okay? And then, so that takes care of this week. How many more weeks we have left? What do we got left on our calendar?
25 days.
Is that school days or
Just school days?
just school days? All right. So this takes us through April 14th. And then so the following week we'd have the Monday, Tuesday, Wednesday is like 20-minute periods, which I'm pretty sure a whole lot of people will miss out on. Thursday, Friday, which this takes us through April 21st. And then we have the Monday, Tuesday, Wednesday, Thursday, Friday, which takes us through April 28th. And then, friends, when is graduation? I didn't put it on the 24th of May?
Yeah.
But you guys are done the week before that, right? The 12th? 12th? Okay. So this takes us through May 5th. And by your guys' terms, May 12th is you guys check out. All right. Well, a few things that might upset you. And I know anxiety is there because school's coming to a close quicker. But I'm going to give you guys some advice, or give you something that I know that we don't have in this class, which should take a little bit of your anxiety off. We don't have a final exam in this class. Sorry. I know you were all anticipating it. You were hoping for it. You're like, dude, Stirrup, can't wait to show you. But I will tell you that I will probably more than likely teach up till this day right here. Okay? Sorry.
Do you have another story?
I'll probably fit something in there. I'll find something for you. All right. Yeah, I mean, dude, you're looking at the remainder of high school right there. And then May 25th, you said is graduation? 24th? Yeesh. Okay. All right. Well, hey, that works. I like it. All right. Attendance is right. And have y'all figured out that I'm not the guy who will realize, oh, shoot, I need to finish up these 15 things, and so I'm going to slam you at the end?
What's the one with the stair? The what?
The Post?
The post. What's that about?
It's got Meryl Streep and Tom Hanks. I haven't seen it published yet. All right. So, page 45, here we come. Ready? Set. Good. I can start finally teaching because Laura got here. Come on, Stuart. I'm sick. And watch, I'm not going to give Jake any hard time, so Laura's going to get all mad because I just make fun of her for being late. Jake, don't worry, you're set. I didn't even mark you tardy, but Laura got the tardy. I'm just kidding. I marked the entire class tardy because you didn't get here on time. Bro. All right. Ready? Yeah, I think we're good to go. All right. You guys ready on page 45? Books out or this page out? Sound good? All right, so this is the very last unit of this chapter. This is the one proportion z-test. Okay? So let's define real quick what a z-score is. What is a z-score? We've done it forever. It's a standard deviation that can have what? Standard deviation that has what? Anybody? It has, it has decimals that are part of it. So you could have a z-score of 2.3, which means technically you're 2.3 standard deviations above the mean. Okay, that's really what it comes down to. Okay, a z-test or a t-test for means seeks to find the evidence that the average of something is less than, greater than, or different than some pre-selected value. So a z-test for proportions seeks to find strong evidence that a percentage of something is less than, greater than, or different than some pre-selected value. The steps for each hypothesized test are shown that given. So state the null and the alternative. Here, gee, what's that? We've never done that. No. Okay, you haven't paid attention. Okay, but this has a population proportion. So it has a percentage or a percentage we could find. So if I said, hey, we found that 8 out of 10, well, the percentage would be 80%, right? All right. It said create the null hypothesis sampling distribution. So create the normal curve, okay, with all the positions, okay? And then the one thing that we need to do, if we are finding the standard error when you're giving percentages is going to be, we've seen this before, it's the square root of the percentage minus the complement, so 1 minus percentage. So an example of something like this, if we knew 30% of students prefer drinking diet soda, you would say, oh, 30% is 0.3, and then, so that would be your p-value, or that would be p, your percentage, and then 1 minus p would give you 0.70, because 1 minus 0.3 is 0.7, okay? And then n is your sample size. Good enough? And then we would have to calculate, the p-value. That's where we use Desmos and the limits. And then your conclusion. So fail to reject. Fail to reject the null or reject the null. Okay? And then check for assumptions. So that's basically check for red flags. And again, my friends, red flags are sometimes kind of are tough to see. Again, use your gut to check red flags. Use your gut. Your gut, your thought process is the number one thing that if you kind of think something seems a little fishy, guess what? It might be. Okay? The person who is presenting you the information might be trying to lead you to something. But then you're also checking for something called normality. And we've used these tests before, but not under the normality thing. The normality is n times p greater than or equal to 10, and is n times the complement of p greater than or equal to 10. And then we go from there. So I saw something last night. What is the new AI program where you could type in saying, I want a 3-page paper and artificial intelligence writes it? What is it called? What is it?
ChatGPT.
ChatGPT. Is that what it is? So my wife, she's a professor at CU Denver, and anything that's submitted, they go through to make sure that it's not plagiarized, because they tested, Turnitin.com. But Turnitin.com now has a item on it where schools will have it. So I'm just giving you a heads up. That will check to see if it's AI, what percentage of the paper is AI generated. And so my wife's like, watch this. So she pulls one of her students' papers, puts it on there, and it said it's 38% AI generated, which basically highlights the portions that are AI generated. And I thought, I don't know. People that are way smarter than me figured it out. So my wife's like, oh my gosh, 38%. And I'm like, okay, we'll do another paper. Well, another paper came out like 1%. And I'm thinking, okay, a 1% that it matches to AI versus a 38%, that's a pretty big span, but I still think 38% is low. And I just kind of, I said, my thought process on that is it possible that somebody typed up a paper and it gets scanned in, and that it could say that it was AI generated, even though it isn't? And I guess that's a reality. And I'm just saying this because we've been dealing for all year about statistics. So I'm just, I'm concerned with your generation, because I imagine if you've never used it before, you might try it. I mean, I've tried it because I was amazed at what it did. Mr. Meow was showing me it, and I thought, oh my gosh. I thought the way technologies are going, but where it comes and where you have to be cautious, especially you all who are planning your next steps, and whether it's college or not, I don't know. And it doesn't really matter if you're choosing to go to college or choosing to work. I'm just saying that, but I just wanted to warn you that you might get into a discussion with a teacher saying, hey, I ran this through and I saw that this percent was AI generated. I imagine, and I told my wife, I said, if you had that student that had that 30% AI generated, but the rest is really their work, maybe not hit that kid right there with the 30% AI generated, but maybe allow that student to think they got away with something. So the next time they submit something and all of a sudden you get a 98% AI generated, that's where you can nab that student. But it was just interesting to think about, going, okay, it gave me a percent that something was AI generated. And I mean, I could type something up and probably submit it through that thing, and it might say that there's a certain percent that's AI generated, even though it was my own thought. So there's the difficulty. Is it, whether you chose to use it or not, or, I mean, one, if you use something like the AI generated and you get caught, well, it wasn't your work. If you didn't use it and they were saying, hey, you did use it because there was a certain percent, I think there needs to be some sort of, like a fulcrum, like a balancing point of, could this be somebody's common thought? Because this is a new, I know that this typing thing up is roughly a year old. I don't even know how long it's been out there.
The AI or
No, I know the turned-in's been in for a while, but the artificial intelligence,
I would say it's about
like within a year, so roughly.
year and a half.
Yeah. So I mean, it's interesting. I mean, obviously, me as a math teacher, I had to contend with the situation of students using PhotoMath. And what cracks me up, I will catch my students who have used PhotoMath on their homework in Algebra 1, and they've given me the first or second derivative of the function that they have. Well, a derivative is no part of Algebra 1. It's like, why do you have the second derivative of this function? Oh, well, I was thinking about how to work it. Can you tell me what a derivative is? Uh-oh. Yeah, you used PhotoMath, didn't you? How'd you know? Because I never talked to you guys once about a derivative in Algebra 1. So, if you don't know what a derivative is, here's your basic skill. If you take a derivative of a function, it allows you to find the slope at an instantaneous portion of the thing to find the tangent line that goes with it. It shows where your graph is increasing or decreasing, whether it's above or below the x-axis. If you take the second derivative, it finds you something called the point of inflection, is where something flattens out, where you all have taken Algebra 2 at some point, where you might have heard the terminology bounce, wiggle, cross. That's where it's all related to with first and second derivatives. Okay, yes, third derivative does exist. First derivative in physics finds you the velocity, or finds you the velocity. Second derivative finds you the acceleration. So there's different things like that mathematically it works for. So I just wanted to warn you. I saw how that AI now works on the Turnitin, and just be cautious. But you also have a wheelhouse of statistics that you took with me all year. So if you get pulled in and the professor says, hey, 30% of your paper is AI generated, you could say, no. We're going to do a z-score based on the one proportional z-test, and I'm going to prove to you that you're wrong. And so I'm just giving you something for your wheelhouse for your defense. Deal? All right. So on page 46, it says the state of Colorado sets carbon dioxide meters around the city to try to detect cars that are in violation of emission laws. Okay, so you might have seen these where you have like a van parked at the end of a freeway on-ramp, and it has cones on either side of the ramp, and there's a little mechanism. That's trying to sniff your tailpipe on your car, not your keister. So they're trying to see if there's any cars that are in violation. The goal is simple. We wish for less than 98% of the cars and trucks on the road to be able to pass the emissions test. Over the course of a week, the auto emission checkpoint is set up at I-225 and I-25. 4,600 cars pass by, and 99.4% of the cars pass the emissions test, and we're going to use an alpha score of 0.05. Okay, so things that we know. We have a sample of 4,600 cars. Okay, item 1, was this a random sample? No. This right here has a red flag right now that they just put at some certain intersection and just collected data of cars that went by. So it's really hard to say that they want to show that less than 98% of the cars or it should be more. They want to show that 98% or more of the cars that pass by are not as throwing as much emissions out into the atmosphere. All right. So we're going to look at this. It says, over the course of the week, the emissions set up at I-225 and 4,600 cars and our sample showed that 99.4% of the cars passed. Okay? And then we want to use an alpha of 0.05. Excuse me. Okay, so one proportion z-test. So our null, which is listed, is we want our p-value to be greater than 0.98. So I convert the 98% to a decimal. And then our alternative is we want p to be equal to 0.98. And I think what we could have also done here is we could have said less than to make it one tail. But right now, as it sits, it's a two-tail situation. Okay? So the null hypothesized sampling distribution would have the following. We'd have a mean of 0.98. And then if we went and found the standard error, they gave us a standard error already, but how would we have gotten to this 0.002? And how they would have gotten to the standard error was by doing the test. So the standard error of this is going to be the square root of p, 1 minus p over n. So what they would have done is they would have went 0.98 and then 1 minus 0.98 divided by the 4,600 cars. And if you did that actual math, it would have came out to 0.002. Okay? So we can easily create our normal distribution. So right here is 0.98. And if we added 0.02 to that, I'd get 0.982, 0.984, 0.986, 986. If I went the opposite way, I'd go 0.978, 0.976, 0.974. Okay, so there's our normal distribution. And then we want to show, we showed that 99.4% passed. So we're over here for an area. Okay, so we're way out to the right. All right. So if they gave us the p-value, but let's just make sure that we can do the p-value okay. So let's just see what our friends, the Desmos community, has involved for us. All right, let's jump down here, check our functions. I want to see if they have the actual z-test, z-distribution, because I don't know if they do or don't. Yeah, we don't have it. So I'm just going to do a normal distribution. Our normal distribution, we know that we have a mean of what we're testing is 0.98. And I know that we have a standard error of 0.002. So hit the plus. So that's our normal distribution based on this. And then we want to find the p-value. So what we want to do is we have to do one direction on this. So I'm going to go to the right because we found our data that we checked from the right was 0.994. So we get that. And I don't even know how I can do this. 1.279 times 10 to the negative 12. put that in parentheses. I have to double it. Or actually, we don't have to even worry about doubling it. I'm sorry, I thought we were doing a two. Oh, we are doing a two-tail. So then I'm going to multiply this times 2 because it was a two-tail situation. So times 2. And so we come up with, so he said the p-value is approximately that. I'm doubling it because I think we have a two-sample test or a two-tail test. Friends, what is that number close to? It has a decimal point with 11 zeros, 258. Is that close to 0? So point 11 zeros, 258. Is that close to 0? I mean, this number right here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that itty bitty tiny, itty bitty smallest number? So what do you think? If our p-value is that, so our p-value, that is so far below our 0.05 that they gave us, okay? So our p-value is below alpha, so we would reject the null hypothesis. We would find strong evidence that the state of Colorado emissions passing rate is greater than 98% based on this intersection. And some red flags is the random sampling is not passed. All cars were at one intersection, so that's a red flag. Did we not sample more than 10% of all the vehicles, Denver vehicles? I mean, you're talking about 4,600 vehicles. You think 4,600 vehicles is 10% of what's out there? And the answer is no. Okay, we're talking about such a small thing. And then if we do check the normality, let's go back here, go here. Go here, go back here. All right, check it for normality. We're going to say is n times p greater than 10. Well, n is 4,600. Our percent is 0.98. And I'd say that definitely is bigger than 10. Then I want 4,600 times 1 minus 0.98, so 0.02. So 4,600 times 0.02. 4,600, oops. 4,600 times 0.02. Well, that's 92, so that's bigger than 10. That's also greater than 10. So normality passes. We do have normality to this. So the normality assumption is passed with the large sample size. Okay, so that's basically what comes in. So red flags on this. We're only checking one intersection. We talked about that in the beginning of the problem, and that could be bad. All right, so what we will go over tomorrow we are interested 612, right? 613 review. So what unit are we on? We are on 612. Where's 612? 614. 613. 613. There it is. So you all could work on page 119 and 120. And we'll go over that tomorrow. We'll basically do it how we've been doing it. You're here, and you write it down. You get the points. If you're not, you better watch the video, and so you can collect those points.